Chapter 15, plug in Chug, problem 33. Use the formula Q equals C m delta T to show that 2,400 calories are required to raise the temperature of 300 grams of water from 22 degrees Celsius to 30 degrees Celsius, and then use the typical specific heat calories per gram degree Celsius. My textbook actually says show that 3,000 calories are required. I think that got corrected in some later versions or later printings of this. It should be 2,400 calories, just in case you have an older textbook that still says 3,000. But it is just straight up a multiplication. Just remember that Q is heat. This is the amount of energy you're putting in or taking out of a system, depending upon if the temperature is going up or down. C is the specific heat. That's the 1 calorie per gram degree Celsius. M is the mass, the 300 grams. And delta T, in this case, from 22 to 30 degrees Celsius, that's 8 degrees. So basically it's 300 times 8 times 1, which is 2,400, and calories is the unit. Now over on problem 34, which is the next one, use the same formula to show that, and it should be 10,056 joules. My textbook has a misprint, and again, I think that got corrected in later printings. 10,056 joules are required to raise the temperature of the mass, same mass, through the same temperature interval. This time we're using different units. Now, if we convert calories to joules, it would be, using the number in the back of the book, it would be 4184 joules per kilogram degree Celsius. And the reason why it's 4190 instead of 4184 comes from the fact that the specific heat of water actually is not, it is not set. It does fluctuate depending upon the temperature. And so presumably 4190 is an average for the 22 to 30 degree range. But in this case, you'll just end up multiplying 0.3 times 4190 times 8, and you should get 10,056. So those are those two problems right there.